Hello students, welcome to Wondercom. We are discussing electrochemistry of first module. I have started some important thermodynamic terms that are related to electrochemical cells. I have already completed entropy out of those terms in my previous video, and in this video I am going to tell about free energy change, or which is also known as Gibbs free energy change or delta G. And I will discuss the importance of Gibbs free energy change in electrochemistry or electrochemical cell. It is important to know for mainly for two reasons. First one is the spontaneity or spontaneous redox reaction, because this is related to this spontaneous redox reaction. And secondly, from this free energy change we will derive the most important equation of electrochemistry, that is Nernst equation, for calculating cell potential at any temperature. So this term free energy is very important and also essential for the spontaneity of the reaction. So let us know what is this free energy and what is this free energy change, and how it is related to this spontaneous process. Gibbs free energy is the energy available in the system to be given off to perform or to do useful work. So one should not get confused with this free energy with the internal energy, where this internal energy is the energy within the system at any time. So this free energy decreases as the work is done during a spontaneous process. So this is that thermodynamic quantity of a system whose value is decreased during a spontaneous process. And spontaneous process is equal to the maximum amount of the useful work that can be obtained from a system. Because this free energy is a state function, therefore the change in free energy always depends on the initial and the final state of the system, and not on the path by which the change has been carried out. And the change in Gibbs free energy takes both change in energy or enthalpy, and entropy of the system into its account. So change in Gibbs free energy is it will consider both the change in enthalpy as well as entropy, and this is known as Gibbs-Helmholtz equation. Gibbs-Helmholtz relationship or the equation. We have seen many chemical reactions or even physical processes involves in releasing different types of energies, which energies can be used to do some useful work. For an example, in case of the burning of fuel inside a vehicle, which used to release energy, and this energy is used to power the vehicle. So you can understand the free energy is that energy which is available in a system to do work or useful work. So the spontaneous reactions release free energy when they proceed. So the sign of delta G always negative. So in a spontaneous process, delta G always negative, or delta G is smaller than 0. Just have a look into this table where you would find the delta G and the reaction behavior. So when delta G is negative, reaction is spontaneous. When it is 0, the reaction is at equilibrium, and for the positive value of delta G, there would not be any reaction to happen. So we know from the Gibbs-Helmholtz equation that delta G depends on the change in enthalpy as well as change in entropy. So there are certain conditions for which conditions under which delta G becomes negative, and that depends on the conditions of enthalpy as well as entropy. So before going for delta G, we should know about delta H and delta S first. When delta H is equal to positive, then the system or the reaction is exothermic. Whereas when this value is negative, then the reaction is endothermic. Whereas delta S, when it is positive, the entropy increases, randomness increases, or more disorderness. Whereas when delta S is negative, means entropy decreases, and this is supposed to be more ordered. So let us see the different conditions of this delta S as well as delta H, where we can find delta G to be negative. Just see this table. When both the values of delta H as well as delta S are positive, then the spontaneity of the reaction depends on temperature. When delta H is positive and delta S is negative, then delta G always positive and the reaction is non-spontaneous. When delta H is negative and delta S is positive, then always delta G is negative and reaction is spontaneous. When both delta H and delta S values are negative, then the spontaneity of reaction depends on temperature. So let us discuss about standard Gibbs free energy change, or this is denoted by delta G naught. So this is this free energy change of a reaction is defined as the change in the free energy which takes place when the reactants are in their standard condition, or the standard condition or the state is that we have already discussed, that is 1 atmospheric pressure and 298 Kelvin, and the reactants and their in their standard state are converted into the products which are also in the standard state. And the Gibbs-Helmholtz equation for this standard state is delta G naught is equal to delta H naught minus T delta naught. So this is the equation for standard state or the standard Gibbs free energy change. Let us see the relationship between the delta G and delta G naught. So see, the relationship between delta G and delta G naught is, for any reaction, this is delta G naught plus RT ln Q, where R is the your gas constant and the value is 8.314 joule per Kelvin per mole. Where T is the temperature in Kelvin, and Q is the reaction quotient. And when the driving force of a chemical reaction is 0, then your delta G becomes 0 and Q becomes equal to K. It is nothing but the equilibrium constant. And so delta G naught becomes minus RT ln K. Let's see the relationship between Gibbs free energy change and cell potential. So when in a galvanic cell, the cell reaction or the redox reaction takes place, then we are getting electrical energy, or electrical energy is produced, or that is, we can say the electrical work is being carried out by the system or the cell. Here cell is the system, which results in the corresponding decrease in free energy. Decrease in free energy that we have already discussed. That this decrease in free energy means maximum amount of work done by the system, or this is negative, or the negative value of delta G, isn't it? Work is done during a spontaneous process where the free energy decreases, and we will get the maximum amount of work done. from the system or the cell. Here cell is the system, and this concept will help us to derive the most fundamental equation of the electrochemistry, that is Nernst equation, which we will derive in my next video. Hope you have understood the concept of free energy change. In my next video, I will use this free energy change or Gibbs free energy change in calculating the cell potential by using or by deriving Nernst equation. So keep watching, keep learning. Thank you.